Hi, I'm Michael, the founder of Steelo, the leader in structural steel. I'd like to show you how we work to support your build. My name is Michael Krajewski and I'm here to talk about the future of structural steel. I started off as an aviation engineer and I worked for GE Aviation Engines, was in the design center. I must say I didn't quite enjoy that work because I felt like a tiny ant doing almost nothing. And I came across the structural steel industry back in 2007, and since then I fell in love in it, and that love affair is still alive till this day. That's how also Steelo was born, because the purpose was to revolutionize the industry. I was shocked at how outdated the steel industry was. After graduating, you see all these fancy machines, robots working, and suddenly you come across the steel industry where everything was done manually. So that was the purpose of our company. We've got a set of values that we follow, and all of this is to make sure we supply a reliable service. But today I'll be talking about the revolutionizing part of the business. We happen to be covered quite nicely by media. They reach out to us rather than we asking them to visit us, which is quite nice. I'm very passionate about time, because in my opinion time is everything. Because if we talk about any innovation, any progress, it all is actually about time. Making things more efficient is time, and obviously reliability means time. So the first question is about the lifespan of structural steel, because if it's a dying industry, then maybe there's no point actually developing anything in the steel world. The facts are that there are some super strong materials being developed in laboratories, but they are just too expensive to roll out on an industrial scale. So bearing in mind that how long it takes to develop these materials, I reckon we've got about 10-20 years at least remaining in the steel industry. So it's safe to focus on R&D in the structural steel world, because there will be a market for it. The most bitter fact about the steel industry, and it's the same in the construction industry, is that the number of skilled workforce is declining. And obviously it is strictly correlated with the cost of labor, and this is something that is forcing us to develop the steel world rather than us trying to develop a technology that will put people out of their jobs. So it's actually the need for finding alternatives because of the demographics. There's a company in the Netherlands, they're called Voortman. They are working on an automated fabrication assembly robot. So basically it's got three welding robots and one electromagnet that picks the item, moves it to the right place, and then the robots continue welding. They've been working on this project for quite some time now. It's been a few years. They've got it up and running in their production facility, but they still can't offer it to the wide market. Reason behind it is because structural steel is very tricky when it comes to the tolerances. The beams aren't skew, and also every single beam is different. It's down to the detailer to design the connection however they wish to. I've looked into getting a grant into doing something similar, although much more basic, but then I realized, well, if someone else is already working on it, then let's just leave it to them and let's focus on something else. And that's how I came across Cranfield University, and then we got in touch with Warwick University, and we're working on 3D printing. So basically it's a robot with a welding head and just welds layer by layer, forming the steel item. And I've got a sample with me. It was obviously cut and then tested, but this is what it looks like. So instead of having a human taking a plate, attaching it to the end of a beam and then welding it, we've got a robot that prints the whole connection. Obviously this is version 1.0. There will be probably 10.0 versions before we will be able to roll it out on industrial scale, but these are the very beginnings of something revolutionary in our industry, and we're happy that we're part of it, and we're also one of the driving forces. So this is a close-up view. And this is not the final idea or the vision for the 3D printing, because it's like if we compare Formula One 30 years ago, the front spoiler looked like that. It was just a simple piece of material. Yes, it did have some curvatures for aerodynamics reasons. But then, thanks to computers, it is possible to design things that humans would never be able to design. And the same as with steel. At the moment, if we look around, we've got these lumps of steel. They're all over-engineered. So the future is in having robots printing the whole structure on-site and printing the most optimized structure. So there, where the load is greater, then the material is much thicker. And in the ends, where there's not much moments, then the material can be much smaller. So it would be much better utilization of material. So yeah, maybe one day, instead of having the lump of steel, we would be able to print this mesh. There are other issues with this mesh, one of them being fire, because the surface of material is much greater. So if this catches fire, then it will melt like crazy. So there are the considerations, but that is where I see the future of structural steel. We've also experimented with artificial intelligence, although we've started a few years before it became the sexy word. We did park this project for some time, but the idea was that for us to prepare a quote, we had to have our estimator scan through all these drawings to find out everything to do with steelwork and highlight it and then extract it into our IT system. So the idea is, well, what if a computer does it? So it just scans the drawings and finds the keywords relevant to steelwork, so even in the text. And we've managed to do it. It had to be a AI software, so it was based on self-learning, so that it finds mistakes, and also if it's at an angle, skew, or sometimes there are different abbreviations used, it will still pick it out. The problem we've come across was that a page of scanned document weighed 12 megs. 10 pages was obviously 120 megs, and very quickly a few projects was a few gigs. And when we started experimenting with it, cloud storage was just too expensive to afford this kind of data build-up. We've also experimented, and it's a very new project, with online ordering. We decided, well, instead of going through the flawed process of the interaction with us as the steel fabricator and the customer, why don't we put the tool of ordering steel straight in the hands of the small builder? And this, I must say, is for the small construction sites. And we've developed a software platform called Mr. Beam, but please don't mix it up with Mr. Bean. We are rolling it out now in builders merchants. We're working with Travis Perkins. We've got a few branches that have rolled it out, and Chandler's around London. So it's a very new thing, and we're also proud to be the leaders in implementing change in the steel world. As part of our growth, we're also looking for consolidation opportunities. The market will definitely benefit from it. If we implement a machine that's 500 times more efficient than a human, then we need the scale in order to make that work. So that's why we're now working on various mergers and acquisitions in order to just make it all feasible. We'll also be exhibiting at London Build next month. I will be manning the stand with others, so I'm happy to talk there. So hopefully we can see you there. If you would like to follow us, then please connect through these social media platforms. And thank you very much for your attention.